Namaste, hola, and welcome. I am GV Pawan Kumar. You're listening to Essays in Global History of Physics as part of the podcast Pratidwani Humanizing Science. All the episodes are freely available online at historyofscience.in. This episode is titled Physics Portal of Aristotle. In the previous episode, we discussed engineering civilizations. Specifically, we discussed how philosophy and technology have played a critical role in the betterment of civilization. In addition, the fact that thoughts and tools have direct implication on how human beings lived cannot be overstated. Over the centuries, there have been many people who have played a critical role in advancing philosophical thoughts and engineering tools that have directly or indirectly influenced the development of physics. Before we really get into the specifics of the science of mechanics and its historical developments, we need to investigate some of the ideas that were part of the discussion in ancient civilization. Given that mechanical tools date back to the prehistoric era, it is not surprising that human beings took an interest in understanding how the world works within their proximity. In such a development, a human being is always curious to understand and harness nature. To do this efficiently, one will have to systematically think about how nature works. According to the existing literature, from a history of science viewpoint, the Greek philosophers occupy a very special position. Part of the reason is that their thoughts were recorded in some form or the other, and these thoughts date back to a period as early as 300 to 400 BCE, or sometimes even before that. This also coincides with the time at which writing became an important tool to propagate ideas, and therefore one can see the emergence of historical evidence from this era. The Greek philosophers have a great reputation in Western philosophy and have influenced the development of scientific thinking for a very long period of time. This does not mean that people from other civilizations did not think about tools and philosophical ideas, just that the availability of written records, either direct or indirect, has been one of the hallmarks of Greek civilizations. Thanks to the accumulation of these texts, either in the primary or in the secondary source form, it has played a critical role in identifying a specific point in Western civilization. Physics, as we know it in the 21st century, has a very different avatar compared to its origin. Among the many Greek philosophers who seriously thought about natural philosophy was Aristotle. Aristotle has had a long legacy of being the student of some great thinkers from the Hellenistic era. Aristotle was a student of Plato, and Plato was a student of Socrates. So these three gentlemen have contributed to Western philosophy in such a great way that one cannot discuss anything about philosophical discourse without bringing them into the picture. The origin of physics, too, has some connection to these gentlemen, specifically to Aristotle, who was guided by some processes of thinking developed by Socrates and fundamentally from his guru, Plato. The Plato school of thinking deeply influenced Aristotle, and yet he paved his own way in Western philosophy. He was also one of the first writers among these philosophers to seriously think about natural philosophy in the form and in the shape that resembles the current day science. His questions were related to natural phenomena, and it is by studying them that we realize Aristotle's contribution. As I always keep saying, it is not just the answers that make great thoughts, it is also the questions that elevate the answers and make them profound. In that way, Aristotle's questions were profound. Therefore, I need to emphasize the quality of the questions that Aristotle asked instead of just emphasizing the answers he gave in the process of this questioning. It also indicates that current day physics, as we now know, is not in the form Aristotle thought about, but we can see a glimpse of some interesting ideas in Aristotle, which turned out to be extremely important. It became so critical that for the next 1,000 years from the time of Aristotle, the Western philosophy and the science that emerged out of it kept Aristotle as an important benchmark and developed its thought either in agreement or in rejection of Aristotle's ideas. So much so that thinking process in reference to Aristotle's ideas not only influenced Western civilization, but also had a very deep implication for Islamic civilizations. Although Aristotle's idea became critical in ancient Europe and Islamic world, its ideas and categorizations of knowledge found relevance across various civilizations. So let's try to get a glimpse of the man himself, Aristotle. Let us look at the biographical details of this remarkable individual and learn about his work. The life of Aristotle. Aristotle was born in Stegeria, Macedonia, which is in the northern part of Greece, in 384 BCE. His father was a physician to one of the kings of Macedon, and Aristotle was probably influenced by his father's way of thinking about nature and natural phenomena. Of course, this is all conjecture because nobody knows the exact nature of the interaction between Aristotle and his father. However, this reconstruction is generally accepted based on historical texts. When Aristotle was around 17 years old, in 367 BCE, he was sent to Athens to join the remarkable institution known as Plato's Academy. During that period, Plato's Academy was one of the leading intellectual centers in Europe, playing a critical role in shaping the thinking of various philosophers, including Aristotle. It was at this place that Aristotle honed his skills in philosophical arguments and the observations of nature and natural phenomena. This foundation played a crucial role in shaping his later works. For approximately 20 years, Aristotle remained at the Plato's Academy. After Plato died in 348 BCE, Aristotle moved elsewhere. Historical texts suggest two possible reasons for his departure. One possibility is that he had intellectual difference with Plato's nephew, who took over the academy after Plato died. The second possible reason is that political atmosphere in Athens had become increasingly hostile towards people of Macedonia. These reasons, of course, remain speculative, although they are mentioned in historical literature. In 343 BCE, King Philip II of Macedon invited Aristotle to tutor his son Alexander. This is the same Alexander whom history remembers as the Alexander the Great, though we will refer to him simply as Alexander. Aristotle played a crucial role in educating Alexander for more than 5 to 7 years, deeply influencing the future conqueror's thought process. After about 7 to 8 years, Aristotle again returned to Athens and established the Lyceum, a school of philosophy that had a profound impact on Western thought. This school had a unique feature. Philosophers often lectured while taking long walks. As a result, the school came to be known as Peripatetic School, recognized for its tradition of philosophical discourse while on the move. During this period, around 330 BCE, Aristotle produced some of the most significant works, particularly in the context of physics. Even before leaving Athens, he had substantial contribution to topics related to biology. However, in the second phase of his career, his focus broadened to natural philosophy, logic, ethics, aesthetics, rhetoric, and even music. This vast intellectual repertoire is one of Aristotle's most remarkable features. Around 323 BCE, Aristotle left Athens again following the untimely death of Alexander. During that period, anti Macedonian sentiment was widespread in Athens, which likely motivated his departure. Within a year of leaving, around 322 BCE, Aristotle passed away at the age of 62. The probable cause of his death appears to have been natural. All this information, of course, is based on historical sources that have passed down through the centuries. One should always be cautious while interpreting ancient texts, as most of these sources survive only in translation rather than the original form. There is always a possibility of inaccuracies, and one must approach these accounts with care. Aristotle's intellectual journey covered a vast spectrum of human inquiry, from the heavens, as in astronomy, to logic within the framework of mathematics, and of course, physics. His interests also overlapped with observation phenomena and the life around him, which is evident from the questions he explored. Among his many areas of interest, we will primarily focus on his contribution to physics. Aristotle's writing on natural philosophy cover a vast range of topics from celestial bodies to the nature of matter and motion. His works, though sometimes speculative by modern standards, laid the foundation for centuries of philosophical and scientific thoughts. Much of what we know about Aristotle comes from the preserved writing of later scholars, as very few primary sources from Aristotle himself remain. Before I discuss Aristotle's book, a few words on the origin of the word physics. The word physics is derived from a Greek word called physiki, which means natural science. This word has its origin in another word, and it is called physis, which means nature in Greek. The modern definition of physics is essentially derived from the Latin word physica, which essentially means the study of nature. This word was adapted by the Old French, which was further adapted by English to be transformed into the word physics, as in natural philosophy. In the context of Aristotle, it is the Greek word physis, meaning nature, is central to this particular discussion. The 8 books of physics. Aristotle's physics is divided into 8 books, each exploring different aspects of nature and motion. Specifically, he was interested in the principles and causes of change and motion of objects. Let me give you an overview of his books. Book 1 introduces Aristotle's fundamental concept of matter and form. A key discussion in this book is the doctrine of the 4 causes: the material cause, which explains what something is made of; the formal cause, which defines its shape and essence; the efficient cause, which refers to the force or agent that brings about change; and the final cause, which represents purpose or end goal of an object or process. These causes provide a framework for understanding physical interactions and transformations. In book number 2, Aristotle argues for teleology, the idea that nature has inherent purposes. He defends the study of nature as a legitimate form of scientific inquiry and lays out a methodological foundation for observing and interpreting natural phenomena. Book number 3 explores the nature of change. Aristotle distinguishes between actuality, the realized state of an object brought about by an external force, and potentiality, the inherent capability of an object to become something else. This distinction is significant in understanding motion and transformation. In book number 4, Aristotle explores the nature of voids, rejecting the concept of vacuum. He also presents an interesting perspective on time, defining it as a measure of change. Book number 5 classifies different kinds of motion, an important step in distinguishing natural movement from forced motion. In book 6, Aristotle discusses the nature of continuity and the concept of infinity. He argues against the existence of actual infinity, emphasizing the finiteness of physical reality. Book 7 introduces the concept of the prime mover, an external force that initiates movement. This idea becomes central to Aristotle's broader cosmology. Book 8 expands on the idea of the prime mover as the ultimate cause of cosmic motion. This notion of an external force influences the universe, has a lasting impact on Western thought, intertwining scientific and theological perspectives for centuries. Related to these books was Aristotle's book titled On the Heavens. In there, Aristotle discusses his celestial theories. The 4-part work explores the natural celestial bodies and their motion. He also proposes that heavenly bodies are made of ether, a perfect and unchanging substance. Aristotle also argued that the earth is spherical and that celestial objects move in circular orbits, a belief that persisted until Kepler's elliptical orbits emerged. He discussed why celestial objects move in circular paths, distinguishing their motion from that of objects on Earth. Expanding on his theory of the 5 fundamental elements, earth, water, air, fire, and ether, Aristotle's ideas parallel similar concept in other ancient civilizations, including Indus Valley civilization and Mesopotamia. Aristotle also studied natural phenomena through observations and a related four-book series were titled Meteorology. These books addressed weather phenomena like clouds, wind, rain, lightning, natural bodies like lakes, rivers, seas, and geological formation, dynamic processes such as volcanoes and transforming matter. Another interesting book that Aristotle wrote about was based on his views on matter. The title of the work is unconventional and reads On Generation and Corruption. This work consists of two books, and it discusses the four elements and their combination, the process of transformation, mixing, decomposition of substance, and hence the corruption of the substance. One may wonder how we know so much about Aristotle, even though he lived around 350 BCE. This is one of the remarkable features of human beings. They carry forward ideas from one generation to another. Of course, this transmission across ages may cause errors in translation, but at least we get a gist of the idea through percolation. The records that we obtain through transmission will depend on the preservation of the sources. This is where the written text becomes so important because a physical text can be preserved, transported, and reproduced with relative ease compared to oral records from the past. Most of the information about Aristotle comes from Corpus Aristotelism. This is a multinational project about preserving Aristotle's work. Around 200 texts are associated with Aristotle, out of which 31 have survived as the ancient textual evidence. These texts are from later eras across different countries, but one can make a connection to the original source through an educated guess and cross connections. So I hope you have got a glimpse of Aristotle and the range of topics Aristotle was interested in from a physics viewpoint. Aristotle's broad approach to physics covered motion, change, matter, and the cosmos. While many of his explanations were later refuted, his method of questioning and systematic exploration laid the groundwork for future scientific inquiry. His emphasis on philosophical reasoning remains an essential part of intellectual history of physics. In this episode, we discuss the origin of physics from Aristotle's philosophical viewpoint. We learned about his life and remarkable scholarly output. Going forward, in future episodes, we will explore other ideas and thinkers from the ancient age whose work you will generally find in physics textbooks. Can you guess what ideas they are and whom I am referring to? Think about it for a while. You were listening to essays in Global History of Science as part of the podcast Pratidhwani Humanizing Science. All the episodes and the relevant reference of each episode are freely available for future exploration at thehistoryofscience.in. Until next episode of Global History of Science, keep exploring the physics in your life. Bye-bye.